In section 1.2, we'll look at the graphs of functions. In particular, we'll locate the x and y intercepts of the graph of a function, determine the maximum and minimum value of a quadratic, and the x value that produces that minimum or maximum. So let's start with the intercepts. There are two intercepts here, the x-intercept and the y-intercept. And these correspond to the points on the graph where the graph of a function intersects the axes. Now, the easy way to remember which one is which is that the x-intercept corresponds to the x-axis, right? And so that means the y is equal to 0. And the y-intercept corresponds to the y-axis, which means that the x is equal to 0. So whichever intercept you want, you set the other variable equal to 0. So let's write out these definitions completely. So the x-intercept is the point where the graph intersects the x-axis, and the y-intercept is the point where the graph intersects the y-axis. And both of these will be important in their own right when we start doing applications. Let's look at example number 1. Find the x and y intercepts of f of x is equal to x squared minus 6x minus 7. Sketch the graph of y equals f of x using the intercepts. So we want both intercepts. Let's start with the x-intercepts. The x-intercepts are where y is equal to 0, and the y is f of x. So we're going to have 0 is equal to x squared minus 6x minus 7. You recognize this equation as a quadratic because the highest power is with the x squared. And you want to see if this factors. And it does. So x squared is x times x. And then we're looking for two numbers that multiply to give us 7 and subtract to give us 6. Well, that would be 7 and 1. And I need this inner sum here with the 6 to be negative 6. So I'm going to make the 7 negative and the 1 positive. And this is still equal to 0. Now, when you have it factored and the product is equal to 0, then you split these up and you set both factors equal to 0 and solve each equation. So we get x is equal to negative 1 and x is equal to 7. And those are the x-intercepts. And in some cases, you'll need to write these as points. So the point is negative 1, 0, because the y is 0, and 7, 0. Next, I want to find the y-intercept. And the y-intercept is where x is equal to 0. And that just means we're going to plug in 0 for x. So this is f of 0, which is 0 squared minus 6 times 0 minus 7, which is negative 7. And that corresponds to the point 0, negative 7. Now let's make a little graph based on these points. So we know that we have a y-intercept of negative 7. We have an x-intercept of negative 1. And another x-intercept of positive 7. And we know this forms a parabola. So it's going to look something like this. And we'll do more graphing later in the semester. Next, let's look at graphing quadratics, and in particular, maximum and minimum. So we know that the parabola always has a max or a min, depending on which orientation the parabola has, whether it opens up or whether it opens down. If it opens down, then it looks something like this, and we say that it has a maximum value. And if the parabola opens up, then it looks something like this, and we say that it has a minimum value. And what's in common for both of these is that the max or the min must occur at the vertex. So the vertex is the point where the maximum or minimum occur on a quadratic, on a parabola. And we have a formula for finding the x value of this vertex. And that formula goes like this. For the function f of x is equal to ax squared plus bx plus c, that's just our general quadratic function, then the vertex x value is h, we call it h, is equal to negative b over 2a. So there's our formula. You need the a and the b to determine the x value of the vertex. Then for the y value, you just plug it in. So k, which is what they call the y value of the vertex, is f of h, where that h is the vertex x value that we get from the previous formula. So what I do is I focus on this formula for the x, and then I just remember that it's a point on the graph. So if I plug in that x value, I'll get the y value, and that y value is the minimum value or the maximum value, depending on the orientation. We know the orientation of the graph based on the value of a. That is the coefficient of the x squared. If the a is negative, less than 0, then the parabola opens down and we get a maximum. And if a is positive, then the parabola opens up and we get a minimum. Let's look at example number 2. The profit for selling x calculators is given by p of x is equal to negative 0.2 x squared plus 30x minus 60. Find the number of calculators needed to maximize profit. What is the maximum profit? Graph the profit function in GeoGebra and find the points that represent find the point that represents the maximum profit. I'll let you do the GeoGebra part on your own so that you can get some familiarity with that. But first we want to recognize sort of the thought process to this. Now, we pretty much know what we're going to do because of what we're doing in this section. But on a test, when this may be just sort of thrown at you, you have to reason through this. Find the number of calculators to maximize profit. So you're looking for a maximum. You know that your function is a quadratic. And how do you find the maximum of a quadratic? So maximum of quad. That should instantly tell you that you need to find the vertex. And now that you know what your strategy is, finding the vertex, you'll know exactly what to do. So we know that the h coordinate, the x coordinate, called h, of a quadratic, is given to us by the formula negative b over 2a. So this is going to be negative 30 divided by 2 times negative 0.2. If you work that out, that is 75. But is it $75 or 75 calculators? Well, this comes from interpreting what the problem says and how the variables were set up. So the profit from selling X calculators is given by P. P is in dollars, X is in calculators. This is an X value. So this is 75 calculators. So in order to maximize the profit, then we need to sell 75 calculators. This is probably on a monthly basis. So then, what is the maximum profit? To find that, I'm going to plug 75 in to the P function, and that will tell me the actual amount of money made in profit from selling the 75 calculators. Well, if you plug this into the P function, you get $1,065. And there you go. By selling 75 calculators, we make a maximum profit of $1,065.